Okay, this is going to be my video on calculating empirical formulas and percent composition. So my example question for empirical formulas is to calculate the empirical formula of a compound containing 38.67% carbon, 16.22% hydrogen, and 45.11% nitrogen. So we are going to assume that there's 100 grams so that doing all the calculations will be easier. And this is where that comes in. So we're going to assume that there's 38.67 grams of carbon because of the fact that there's 38.67% and 38.67% of 100 is 38.67. Okay, so we're going to multiply that by 1 mole of carbon over 12 grams of carbon. This number comes from the periodic table of how much carbon weighs. Now from this, you are going to get 3.22 moles of carbon. Now you see that I crossed out grams of carbon. That means that is because you're going to cross out your units until you are left with what you want, which is moles. Okay, so you have your 3.22 moles of carbon. And now you are going to do your moles of hydrogen. And you're going to have 16.22 grams of hydrogen, which is what we get from here. And that is going to be multiplied by 1 mole of hydrogen, which is what you want, over 1.008 grams of hydrogen, which is what hydrogen weighs on the periodic table. And that's going to be equal to 16.09 moles of hydrogen. Now we're going to do the same thing for nitrogen. 45.11 grams of nitrogen times 1 mole of nitrogen, which is what you want, over 14 grams of nitrogen found on the periodic table. Cross out the units, and you're going to get 3.22 moles of nitrogen. Now the reason these are over 1 is just because I was keeping it so that there is no confusion of what's the numerator and what's the denominator. So now what we're going to do is we're going to divide each of these numbers by the lowest number out of the 3 of these. And the lowest number is 3.22, and there's 2 of them here. So what you're going to do is you're going to divide each of these numbers by 3.22, and I do that down here. So you're going to have 3.22 moles of carbon divided by 3.22 is equal to 1. That's going to be 1 carbon. There's going to be 1 carbon in the answer, so you see there. Now you're going to do 16.09 moles of hydrogen over 3.22. That's going to equal to 5. So it's going to be 5 hydrogens. As you see here, H5. Here, let me make sure this 5 looks right. There you go. It looks more like a 5 than an S, which it originally did. And now you're going to do the same thing for nitrogen. So you're going to do 3.22 moles of nitrogen over 3.22, which is going to equal to 1 nitrogen. So you can end up with 1 nitrogen here. So the final empirical formula, so let me write this. Empirical formula is equal to CH5N. Okay, so now we are going to do a problem on percent composition, which I have here. So the question is to find the percent composition of each element in the chemical formula C2H5, let me rewrite that 5, OH. Sorry if that 5 here looks like an 8, it is 5. Sorry about that. So now we're going to find the total weight of the whole substance and compound. So we have 2 C's, C2 here, and that's going to be equal to 2, it's because there's a 2 here, times 12, which is how much carbon weighs. So 2 times 12 is 24. That's 24 grams of carbon. Now we have H5 and H, so that's H6 technically. So we're going to have 6 here, and since hydrogen is only equal to 1, it's going to be equal to 6 grams of hydrogen, the whole thing. And there's oxygen, and there's only 1 oxygen because there's no subscript, which is understood 1. So 1 times 16, which is how much oxygen weighs, and you have 16 grams. Now if you add 24 plus 6 plus 16, you get 46 grams. Now you're going to do some division. since there is 24 grams of carbon in total, you're going to divide 24 by 46 to get the decimal of how much carbon is in just one. So you do 24 divided by 46 and you get 0.52. Now to get a percent, you're going to have to multiply that by 100 and you get 52%. Next, for hydrogen. There's 6 grams of hydrogen over the total 46 grams, and that is going to give you 0.13. You're going to multiply that by 100, and you're going to get 13%. And that is 13% hydrogen in the whole thing. Now, oxygen is going to be the same deal. You're going to do 16, which is how many oxygen there is, over 46, which is the total. That's going to equal to 0.35. And you're going to multiply that by 100. It's going to give you 35%. Now, from that, you're going to add them up, and if it gives you 100, that's good. 52 plus 13 plus 35 is equal to 100. Now, if it is close, like if it gives you like, let's say it gave you 51.9 here. That means this would add up to 99.9. That is okay. It is correct. It's just because they want you to round it, and this isn't without rounding, but if that did give you that, just know that it is still correct. So, you know here that carbon is equal to 52%, hydrogen is equal to 13%, and oxygen is equal to 35% of the whole composition. Now, so that you know it is actually me and not me copying off someone, I'll sign. If my pen was working, there we go. Let me sign it. There. So that you know it is me doing the video and not me copying off someone. Thank you for your time. And by the way, I got into NCSSM.